Hey there, Patriots. Let's go ahead and move on to Lesson 3 in Unit 5. Last time we covered how to convert from standard form to vertex form using completing the square. And today we're really going to hone in on what to do with vertex form once we have it. Now, vertex form is honestly a really nice format for a quadratic to be written in because you can read the vertex directly off of the equation. So our vertex form is y equals a times parentheses x minus h squared plus k. Now keep in mind that this negative sign right here means we're going to be flipping the sign, the whole idea of inside lies. And a is going to be our stretch or shrink and reflection. So the vertex is always going to be at the point hk. The axis of symmetry will be x equals, and just like before, it's going to be right there with the x coordinate, so right there at h. Our domain, as always, is going to go from negative infinity to positive infinity. And our range, well, it depends on whether or not a is positive or negative. If a is positive, then the range is going to be from k to infinity. If a is negative, then it's going to go from negative infinity, that should be a parenthesis, not a brace, from negative infinity to k. So just as an example, I'm not going to worry about specifically where these points are. I'm just putting it on there. So there would be our vertex. We're going to then go up. And so this point right here is at hk. And then our axis of symmetry is going through right there. And we'll get more practice on those specifics as we do our problems. Okay, so for number 1 here, let's go ahead and list the transformations that are going to happen on this. And these are going to be just like the transformations we did back in unit 1 or 2 units ago, whichever one it was, where we did parent functions. So this minus 7 right here, remember inside lies is going to go the wrong direction. That is going to, I guess let me write the word shift, right by 7, and then down by 1. That down by 1 came from the minus 1 right there. Now, also don't take the bait on this. This final value here, that is not the y-intercept. Y-intercept only occurs... Okay, sorry, I'm going to try and pick up where I left off, but that was 10 minutes ago. I paused the video because I had a phone call that came in. I believe what I was saying was that the don't take the bait that this negative 1 here is the y-intercept. That's actually the y-coordinate for the vertex, not the y-intercept. That only happens whenever you're talking about standard form. Okay, the only other piece we need here for our transformations is this 3, and that's a stretch by a factor of 3. So our vertex, we're able to read directly off of the equation. We've got our 7, and it's going to be positive 7 because we have to change the number on the inside, and then negative 1, which means that the axis of symmetry happens at x equals 7. Now, to find the y-intercept, what we're going to have to do is substitute 0 in for x, because the y-intercept happens at the coordinate x comma something. So we're going to go ahead and go y equals 3 times x minus, instead of x we're putting a 0, minus 7 squared minus 1. So that gives me 7 squared, so that's 3 times 49 minus 1. 3 times 49 is 147 minus 1, so it's 146. So my y-intercept at 0, 146, which honestly I can't put in this graph, so I'm not going to be able to graph it anyway. Okay, domain is going to be negative infinity to infinity, and the range I'll come back to in a second. Actually, no, I won't. I'll give you this. When a is positive, it's going to go from k, which is negative 1, to infinity. I'm reading that off of that one there we did up top. So let's go ahead and plot our points. We're going to go ahead and graph the vertex at 7, negative 1. Now we're also going to draw our axis of symmetry. I'll put that at 6. 7, negative 1. We're going to draw our axis of symmetry. And I'm going to go ahead and use this exact same XY chart that we've been using this whole time. 1, 1, 2, 4, 3, 9. And then multiply by the A value. So multiply times 3, which is going to give me 3, 12, and 27. So I'm going to go right 1 up 1, 2, 3. Right 2 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 27 is not going to fit. I'm also going to reflect both of those points over the axis of symmetry and then draw the line, and then you can verify that sure enough my range does go from -1 at the bottom to infinity at the top. Okay, let's go ahead and run this one. Actually, to simplify things down with all my classes in person, I've gone ahead and skipped this one as well. So skip number 2. We'll do number 3. Okay, vertex, we're going to read directly off of the equation again. 4 is going to change, or -4 is going to change to a +4 for the x, +8. So 4, 8. Then what we're going to do is this a vertex, a maximum or a minimum. Well, we know that it's a negative, so it's going to be reflected. The general shape is going to be this way, so it is going to be a maximum. Axis of symmetry happens at x equals 4. We pulled that directly off of the vertex. So let's go ahead and draw that in. Now the y-intercept, we're going to go ahead and plug in 0. So we've got y equals -0 minus 4 squared plus 8. Well, 0 minus 4 is -4 squared, makes -16 plus 8. So that's going to be -8. So 0, -8. We'll go ahead and plot that. Now our domain, as always, is -infinity to infinity. And then the range, we said, starts at -infinity. Since a is negative, we're going to use that bottom one I gave you at the top, from -infinity to k, which is 8, and then close the bracket. Now also to get some more points on here, we're going to use our same XY chart, 1, 1, 2, 4, 3, 9. And this time we're just multiplying by a -1. So that's -1, -4, and -9. Over 1, down 1. Over 2, down 1, 2, 3, 4. Over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Reflect both of those points over. And there we go. So now 4 and 5 is a maximum or a minimum value. Well, let's go ahead and pick off our vertex here. The vertex is going to be at 25, 1, 30. Remember again, change that sign for the x. Now, is it a max or a min? So A is positive, which means my general shape is going to be pointing up. And so that makes it a maximum. Oh, I'm sorry. The vertex down here is the bottom, so it's a minimum value. And the minimum value is 130. Okay, over here on number 5, we got negative, so it's going to open up this way. Makes that a maximum value. The vertex is going to be at 3, -4. I'm going to change that sign. And therefore, the maximum value is at -4. So problems like that go pretty fast. All right, number 6, we've got this quadratic. We want to, from the graph, be able to write the equation. So first off, let's pick off our vertex. Well, my vertex is right here, which is at 2, 4. Axis of symmetry happens at x equals 2. We know that because it happened here. Now, is it going to be a max or a min? Well, looks like it's a maximum. Domain, as always, -infinity to infinity. And then from -infinity to 4. And now to find the a value. Now, notice what we've been doing this whole time with the XY chart. 1, 1, 2, 4, 3, 9. We've multiplied by something to get a list of points over here. We're going to reverse engineer that. We're basically going to go out and find one of the points that this passes through and then figure out what number we'd have to multiply by to get it. So I'm looking over here and I can see that we go through this point right here, which means from the vertex I go right by 1 and then down 1, 2, 3. So that means that this would actually be a -3. So what would I multiply 1 by to get -3? Well, that's the easy one. It's -3. So now I can write my equation. Y is equal to -3 times x minus my h value, or my x coordinate is 2, and then plus 4. So there is the equation of that graph. Okay, now let's go ahead and go through our vertex. That's going to be at -3, 2. Axis of symmetry is going to happen at x equals -3, which was right here. This is a minimum value. Domain is -infinity to infinity, and from this time we're going from 2 to infinity. Now for our a value, let's go ahead and get this set up. I'm looking for a point that it exactly goes through. And at 1, I'm kind of halfway in the middle, but I don't want to take that for granted. I want to go over and say right here. Okay. So here I would go over 2 and then up 1, 2, 3, 4, 5, 6. So here I'm going to put the 6 right there. So what am I going to multiply by to get from 4 to 6? Well, another way to do that is to say it's just 6 divided by 4, which is 3/2 or 1.5. Either of those work. I prefer writing it as 3/2 or as a fraction when possible. So my equation here is going to be y equals 3/2 times x minus -3. So we're going to change that around to plus 3 plus 2. Okay, one last thing we need, the roots of a problem. Roots are also known as solutions or answers. They're also known as x-intercepts. So if I ever ask you for the root, I'm just asking you where is it across the x-axis. So whenever I look at this particular graph, I can see that it crosses here at -3 and at 2. So my answers here are x equals -3 and x equals 2. That literally means that it's the point -3, 0 and the point 2, 0. So if I wanted to, I could go back through all these and look and see where they cross. On this one, I mean, it's going to be somewhere around 3.2, maybe 3.25, and then 0.75, something like that. But this one over here is interesting because it doesn't actually touch the axis. So in this particular one, there are no roots or there are no solutions to the problem. The reason for that is if I was to try and go through and solve this, plug a 0 in for y and solve, you would get imaginary numbers as the answers there. Also, one other type that we can have here is you could have one that comes in and the vertex is directly on the axis. Okay, in that particular case right there, that is known as a double root. And there's only one answer, but basically what we're saying is that it hits the axis twice at the same point, which doesn't exactly make sense, but basically instead of it going down and through, it goes down and just bounces off. So both zeros or both roots end up being at the exact same point. Okay, number 8, trajectory of Vargas's kickoff is modeled after this equation. X represents our horizontal distance, so horizontal distance, and Y represents the vertical distance, both of them in yards. So first off, how far does he kick the ball? Now we say, how far does he kick the ball? What we mean is, where is the ball's going to go up, and don't quote me on this thing, but the ball's going to go up, is going to come down, and it's going to hit the ground somewhere. We want to know where is that second x-intercept? Where is that root? Okay, then how high does he kick the ball? Again, when it goes up here, we want to know what is the y value at the vertex. So those are the two things we need to do. Now, what I'm going to do is I'm going to first look at what is the y-intercept of this particular function. The reason I want that is I want to know where does this whole thing start. If he's kicking a football, I guess it really just depends on, is he kicking it off the ground or is he kicking it raised off the ground? Now it says kickoff, which means usually a kickoff is on a tee right at ground level. If it was a punt, he would be holding it a foot or two off the ground when it makes contact with his foot. So I just want to make sure that this actually does end up leaving the ground whenever at the very beginning. So I want to make sure that first x-intercept is right here at 0, 0. The way I do that is by finding the y-intercept. So y equals negative 0.1 times 0 minus 24.5 squared plus 6. And then let me grab my calculator here. So negative 0.1 times 0 minus 24.5 squared plus 6. And I'm going to hit go to because I forgot my parentheses. Just start over. Negative 0.1, open parentheses, 0 minus 24.5 squared plus 6. Oh, you know what I messed up on? That's a 0.01. That makes sense. Let me put that again. Go over to the beginning. Do 0.01. Okay, I just realized what I did wrong on that one. And what I did is I forgot the squared in there. Second insert, squared. Boom. All right, so it goes through the y-intercept is negative 0.0025, which is close enough to us calling that 0, 0. Okay, now I'm going to find the vertex. Now the vertex, because this is in standard or in vertex form, we can read the vertex directly off of the equation. It's going to happen at 24.5 and then positive 6. So if I go over here to 24.5 and go up to 6, it's going to be right there. Now, because the axis of symmetry happens through the vertex, I can take this y-intercept, and this is why I needed the y-intercept, and reflect it over. Now, if this distance is 24.5, then this distance here is also going to be 24.5. So 24.5 times 2 means it's going to cross or hit the ground over here at 49. So the path of that football is going to go up like this and then down and hit right there. So how far does he kick the ball before it hits the ground? Well, 49 yards. Now, how high does he kick the ball? Well, now we're looking for the maximum height, which is going to happen right there at that vertex, and we already said that that one happens at 6 yards high, which quite frankly is a little bit short for a kickoff. It's 18 feet tall, but hey, whatever. We made this problem up just to make it work. So anyway, that's all we got for you. Let me know if you got any problems.